Taking a look at a more complicated exponential expression right here, let's follow the exponent rules and kind of this order for simplifying. We're first going to be taking care of zero exponents. Anything with a zero exponent is going to turn into a 1. We're going to apply the power rule. If there's an exponent outside of parentheses or outside of other exponents, you can apply power rule. Negative exponents are going to change places. They're going to become denominators, and denominators are going to rise up and become numerators. We're going to combine like bases, and we're going to simplify any numbers that have exponents on them. So the first thing I see here is that I have a 0 exponent here. That's going to become a 1, blend in with the wall. This guy's a 0 exponent. He's going to become a 1 and blend in. I'm then going to rewrite my work. Now you don't have to, but it really helps you keep your work organized so you don't make mistakes. Always make sure that you write down exactly everything else that you see. A lot of students screw this part up because they miss one term when they're rewriting their work. The next thing we're going to apply is the power rule, and I have one power rule application here. This little guy is going to apply there, there, and there. I'm going to rewrite the work again. 6x to the 5th in the numerator, and then I have 2 to the 3rd, x to the 3rd, y to the 2 times 3, because you're going to multiply these guys together. So that becomes y to the 6th, and then I have still times 3, y to the negative 1. Next, we're going to take care of the negative exponents. So here's my negative exponent right here. He's only applied to the y. Some students will try to apply the negative exponent also to the 3, but that only works if you have parentheses around both things. So the negative 1 only applies to the y. He's currently in a denominator, so we're going to bring him up, stick him in the numerator. I rewrite my work again. Now it's just y to the first power. Since it's a first power, I don't have to write the 1 again because it's just y. In the denominator, 2 cubed, y to the 6th. The next step is we want to look at our like bases. The base is the number that is below the exponent. So I have x's are like bases here, and the y's are like bases. If I were to expand this out a little bit on the side, I have 5 x's in the numerator, 1, 2, 3, 4, 5, and 3 x's in the denominator. When I simplify those, I cancel out the pairs, and I'm left with 2 x's in the numerator. So I'm going to have 6x squared in the numerator. And when I look at the y's, I have 1 y in the numerator and 6 y's in the denominator. So if I cancel out one pair, I'm left with 5 y's in the denominator. So I'm not going to have another y in the numerator. I have 2 cubed and y to the 5th. Okay, next step, now that I've combined like bases, let's also look at how you can simplify the 6 and the 2 cubed. I can rewrite 6 as 2 times 3, and I can expand the 2 cubed. 2 times 2 times 2, and y to the 5th. Notice now that I can cancel out a pair of 2's. So I'm actually going to be left with 3x squared in the numerator, 2 times 2, or 2 squared, is 4 in the denominator, y to the 5th. That is fully simplified now because I don't have any zero exponents, negative exponents. All the like bases have been combined, and I have simplified all of my numbers. Here's another messy exponential expression. 3r to the 0, s to the negative 3, all raised to the negative 2, times 3r s to the 5 times r squared. I'm going to start by wiping out my terms with a 0 exponent. That just becomes a 1. Then I'm going to apply the power rule. So this negative 2 is going to apply to each of these remaining terms right here. So when I write this out, I'm going to have 3 to the negative 2, s to the negative 3 times negative 2. So negative 3 times negative 2 is positive 6, times the next part over here, 3r s to the 5th r squared. Okay, next part, I'm going to take care of this negative exponent right here that only applies to the 3. He's going to become a denominator. So I'm going to have 1 over 3 squared. And then we have times s to the 6th and 3r s to the 5th r squared. I now want to start combining like bases. So I have this s to the 6th times 5 more s's, and I also have an r times 2 more r's. So we can also put all of this stuff basically over 1. And when we smash those two guys together, we're going to get s to the, excuse me, let's bring the 3 in the front. Then r times r squared ends up being r cubed. Then we have s to the 5th times 5 more s's. That's s to the 11th power. All of that is in the numerator over this guy right here. He's going to go in the denominator, 3 squared. And now you might notice that you have two bases here of 3. So you have a 3 in the numerator and 2 3's in the denominator. So one of those can cancel with one of those, and we're left with r cubed s to the 11th all over 3. I'm fully simplified because I don't have any 0 exponents. I don't have negative exponents. I've combined like terms, and my numbers are all fully simplified.